All right, so we are going to hit the chain rule again in topic 33. Yesterday we did the two-layer M&Ms. Now we're going to have some potentially peanut M&Ms. So here's what I want you to do. Let's see if you remember. And you can do it right here in this box. I'm going to write it below, but I know you have stuff in these boxes. I want you to write, if I said write the formula for the derivative of f of g of x, what would that be? Okay, what's the formula? Because you have to know the formula, and hopefully you wrote down, you take the derivative of the outside, evaluate it at the inner, times the inner function. That's what that formula is. But like I said, when you're actually doing the chain rule, you might not think of that formula. But let's see if we can do some trig. So the idea is the same. I think you did how many examples yesterday? 4. So we'll go down here, last 3. So cosine of 6x. Do you see? I hope you see this. Again, this is just a two layer. So hopefully you see your layers. The inner function, that's your g of x. The inner is 6x, that's the inner. And the outer is the cosine of something. So if I have to take the derivative of both parts, well, the derivative of cosine is negative sine of the something times, now let's do the derivative of this layer, that would be 6. And remember, what goes in the parentheses is basically all that's in the next box. So, or I say what was in the parentheses here, 6x, so that doesn't change. The arguments of the trig functions will never change. So my final answer would be negative 6 sine of 6x. So why don't you try this one? Why don't you try tangent of x squared plus 1? Stop the video, see what you think, and come back. Hopefully, you said tangent of something is the outer, the inner is x squared plus 1. So the derivative of tangent of something is secant squared of that something times the derivative of x squared plus 1, which is 2x. Arguments don't change. And really, there's not a whole lot to do to make that answer prettier. I just, like I said, I like putting the 2x in front. And that would be my derivative. Well, let's go to this next one. Let's do secant. I'm going to do this one first. Sine, change my mind. Sine of 9x plus 1 to the 4th. Now, I'm going to be honest. I'm going to write down my next example, and I'll give myself a little space. I know you're out of space. Just do it right below. My next example is this, secant to the 5th of 3x. I want you to look at both of those because they both have some similar things. They have a trig function, they have some argument, and then you have a power. But where the power is certainly makes a difference. So I want to be very clear. In this example, the 4 is raising to the power 9x plus 1. In this example, this is really saying secant of 3x all raised to the 5th power. Sorry, got my examples mixed up. All raised to the 5th power. So that's raising the secant, but this 4 is not. So let's do this one first. Let's look at our layers. Now I will tell you both of these have a 3-layer. They're peanut M&Ms here. And so for some people to do the layers, again, some people do outside to inside, some people do inside to outside. So whatever you see better, if you do inside to outside, you think, if I plugged in a number for x, what would I do with it? Well, the first thing, the inside, because remember in compositions you work inside out, you would do 9x plus 1. Then you would raise that to whatever you got there, you'd raise to the 4th. And then whatever you got there, you would take the sine of that. So let's do the derivative of each layer. The derivative of sine is cosine. The derivative of something to the fourth is power to the front, decrease the power by 1, and then the derivative of 9x plus 1 is 9. Now your parentheses, you have to think of, and honestly I usually fill out my parentheses as I go, but just since it's our first time, well, what was I taking the sine of? Well, I was taking the sine of all of this. Remember, if you're doing your boxes, what goes in the parentheses are basically the next two boxes. So this is going to be, this is really small. I would have 9x plus 1 to the fourth power. Okay, see how it's kind of the same of what you have in the next boxes to the right. This one, well, what were you raising to the fourth? What you were raising to the fourth is 9x plus 1. So my final answer, let's combine the 4 and the 9, so that would be 36. I'll go ahead and put the 9x plus 1 to the third out in front. And then the cosine of 9x plus 1 to the fourth. So that would be my final answer. Again, the arguments of the trig functions don't change. What are you taking the sine of? You're taking the sine of 9x plus 1 to the fourth. So the derivative of that is cosine of all that stuff as well. So the argument does not change. All right, let's look at the next one. See if you can figure out your 3 layers. I like to look at it this way. My outermost function is something to the fifth. Then I have the secant of something. Then I have 3x. Now really somebody could say, well, Ms. Pruitt, couldn't I just kind of say what you said, that if the power is on the outside, can I just do the power rule? Yes, because think about what I'm doing. Power to the front, decrease the power by 1, but you don't stop there. What do you keep saying? Multiply by the inner derivative. But here's what you have to realize: when you're multiplying by the inner derivative, that in itself is layered. So see how you have these 2 layers. Well, the derivative of secant of something is secant tangent. Notice my argument doesn't change. And I then have to multiply by the 3. So if you see the 3 layers, see you have the power rule. That was this part. Power to the front, decrease the power by 1. What's the derivative of secant? Secant tangent. What's the derivative of 3x? 3. So you have your layers there, and my final answer, written nicely, would be 15 secant to the fifth of 3x, because I can multiply those 2 secants together, and tangent of 3x. And that in red is my final answer. Okay, let's try some more. Again, if putting it in the boxes helps you, then by all means you don't have boxes, but you can split it up like this and do the derivatives underneath. So let's try some more. So you try examples 1 and 2. Well, do example 1 and stop, and then we'll get to example 2. So with example 1, now I hope you didn't think to say, oh, I got to do the product rule because I have that 3. I don't have to do the product rule because it's not 3x. So that 3 is just to kind of come along for the ride. So really what I have, and I'll do the chart thing in this one since some of you like it, I have the sine of something, and I have x squared plus x. So the derivative, I really have 3 sine of something. That 3 is just going to come along for the ride. So I'm going to have 3 cosine of that something times the derivative of 2x plus 1. I'll slap that in parentheses. Now again, whether they distribute or not, I'm not too concerned with that. So I have, what I'm saying is, if they didn't distribute, and left it as 3 times 2x plus 1, cool. If they distribute that 3 out, cool. But I have this times the cosine of x squared plus x, and that's my derivative. Now let's look at number 2. Now I will tell you that one thing that's added with the trig is, oh shoot, I've got to find the answer, and I purposely made this multiple choice. So let's just start by you finding the derivative. So again, stop the video and try to get the derivative. Don't worry about the multiple choice, just do the derivative. I'm hoping that you wrote it like this. So you saw a 3-layered thing. You saw 1/6 and something squared. You saw the cosine, and you saw the 3x. So those are your 3 layers. So let's do the derivative of each layer. Power to the front, so 2 times 1/6 is 1/3. Decrease the power by 1, so that would be cosine of 3x. The derivative of cosine is negative sine, and that would be a 3x. And then the derivative of 3x is 3. So what I really have, if I multiply that all together, because remember these are just all multiplication, this 1/3 and that 3 actually multiply out. So I have negative cosine of 3x sine of 3x. So hopefully, is everybody with me to that point? Okay. But unfortunately, that answer is not there. So you're like, what did I do wrong? Well, you didn't do anything wrong, except for the fact that you think that you're done, and you're not. Because here's where your trig identities come in. When you have multiple choice with trig, if you get to a point where you think you're doing it right, but you don't see your answer, you need to think of identities. Now let's see what this identity is. Cosine times sine, cosine times sine. What identity do you know, and I'm going to erase so I have some space here. What identity do you know has sine and cosine, sine times cosine? And hopefully you're saying, oh, that's sine of 2a business. So remember that the sine of, I don't want to use x because I don't want to confuse you, is 2 cosine a sine a. Now what I'm trying to do is I'm trying to kind of use this to kind of get back to this. So what I really have, let's see if you agree with me. I have cosine of 3x and sine of 3x. So my a's are like 3x's. So I could write 2 cosine of 3x sine times 3x. What would that be equal to? Well, that would be equal to the sine of, if this is 3x, if this is a and this is twice that, then are you with me that this would be a 6x right there? Okay. Now here's what I'm trying to do. I've got to get that right side to look just like this. So I have the cosine of 3x and sine of 3x. I could divide by 2. Cosine of 3x, sine of 3x. I've got the 3. So I'd have 1/2 sine of 6x. And then I slap a negative. All right, if I put a negative there, I'd have to put a negative there. And now I do have an answer that is on my paper. So this one with the multiple choice would be the correct one. So not only do you have to remember the chain rule, you're going to have to use those trig identities as well. All right, let's try number 3. We're just building, and that's what I hope you see with calculus is, man, you got to get things, you got to understand things from the get-go because they're going to come back and you're just building and building and building. Write the equation of the tangent line to that equation at x equals pi over 6. Well, we've written tangent lines. What do you need? You need a point. So let's get the point. That means I need to find y of pi over 6. Now again, you don't have to write all this. I'm writing because I'm doing notes. You could do this in your head and that's fine. But you have to do the sine of pi over 6 plus cosine of, this says 2x. So 2 times pi over 6, that's pi over 3. So what is the sine of pi over 6? We got to know our trig functions. That's 1/2. And the cosine of pi over 3, well, hey, that's nice. The cosine of pi over 3 is also 1/2. So I get that the point is 1. Pi over 6, comma 1. All right, let's look at the slope. To get the slope, I'm going to need to find the derivative. So I either write y prime or dy dx, whichever you prefer. Let's find the derivative of this thing. Well, with the plus, I'm just going to go down the line. So the derivative of sine is cosine. But the derivative of cosine of 2x, I hope you remember the chain rule. Do not tell me it's just this. It's not negative sine of 2x. It would be negative sine of 2x times what? Times 2, because it is layered. And as you get faster, you just kind of put the 2 in front because you like that. So you have y prime at pi over 6 is going to be the cosine of pi over 6 minus 2 times the sine of, and again, 2 times pi over 6 is pi over 3. So what does that give me? Cosine of pi over 6, now we're talking about here, so long in the x, so square root of 3 over 2, minus sine of pi over 3 is also square root of 3 over 2, but I'm multiplying by 2. So I have 3 square root of 2 minus 2 square roots of 2. Well, 1 minus 2 of anything is just going to be negative of that thing. So I have that. So I have my point, I have my slope, and I can rock out the equation of the tangent line. And that would be my final answer. So we're doing similar questions of things that you have done before. All right, last couple. You try this one. Stop the video, give it an effort. All right, what's the derivative of that? I like to rewrite that. This is really sine of 2x to the 1/2 power. So if you like the boxes, I have something to the 1/2. I have the sine of something, and I have 2x would be my layers. So my derivative is going to be power to the front, decrease the power by 1. That's the power rule part. I have the cosine of something, and I have 2. Of course, what goes in here is 2x. What goes in here is sine of 2x. If I multiply those all together, then that 1/2 and that 2 cancel. I'm cleaning it up just to make it pretty. So my derivative, f prime, is going to be the cosine of 2x over, again, lots of times with negative exponents in case they just ask this. That would be the kind of the cleanest way I could write that. And so if I'm doing f prime at pi over 4, then I get the cosine of pi over 4 times 2 is pi over 2. And the square root of the sine of pi over 2. Well, the cosine of pi over 2 is 0. The sine of pi over 2 is 1. I get 0 over 1. So yes, I know it's frustrating. I did all that for 0. People always say, I hate when I get 0 for an answer. Love it if it's the right answer. So f prime of pi over 4 is equal to 0. It's very messy. So I get that. So do you see how I kind of, again, I use the chain rule within the problem. While doing the problem, I have to think of chain rule. Now I love example 5 because example 5 is the question where yesterday when I said, guys, I promise you somewhere on the AP test, somewhere on my test, I will test you with the formula of chain rule. Well, this is that question because you have to know the formula. Notice what it says. It gives you all this information. G of 2 is negative 2. G prime of 2 is 4. I'm not going to read it to you. You can read. But the question says, find f prime of 2 if f of x is the composition of h of g of x. See, if you don't know the formula for the derivative, then you're kind of stuck. So f prime, what's the formula if the letters were h and g? It's the derivative of the outer evaluated at the inner times the inner function. Derivative of the inner, rather. Okay, the derivative of the outer evaluated at the inner times the derivative of the inner function. Now, if I want f prime of 2, I'm just going to replace all those x's. My x is specifically 2, and then I'm just going to do the math. So let's check it out. What is g of 2? I look up here, I look carefully. G of 2 is negative 2. So I have to find h prime of negative 2 times, do I know g prime of 2? I believe so. G prime of 2 is 4, so I can just replace that with a 4. Now what is h prime of negative 2? H prime of negative 2 is 7. So I have 7 times 4, so f prime of 2 is equal to 28. They gave me some extra information there that I didn't really need, so the only ones I really looked at are those that were underlined. So that's what I mean about how they're going to test the formula in some way. There's no way for you to do this problem if you don't know that formula. So make sure you know that. All right. So work on your assignment. Remember with the answers, you're going to have to think trig identities on some. If you don't see the answer, you know, they have the box there. If you don't see that answer, then make sure that you are thinking about trig identities before you look at the solutions. All right, peace out.